Gimli from Smiling Friends is such a cool character design. I mean, just look at him.
Oh my gosh.
Oh, okay, maybe you shouldn't look at him, but his design is still hella cool. Recently I started rewatching the whole show, and when I got to his episode, a question came to me. Could his design be replicated in a video game? And the answer to that question is obviously yes, since I made a whole video about it. Anyways, welcome to Experimental Gamedev, a new series I'm starting where I try to turn the most random things into games. Also, if you're new here, please subscribe so that I can get a dopamine boost from the silly number going up. If you take a clip of Gimli and analyze it, two things stand out. First off, his model's vertices snapped, which is a callback to PS1 games, where models also snapped around since coordinates were always rounded to an integer. Secondly, his resolution is much smaller than everything else in the scene. This is the thing I will be focusing on, since while vertex snapping is cool, it's not really experimental. I've used it in projects before, and many other games have used it before as well. To start things off, I made a simple character controller so that we could walk around our test scene. I also imported a player model, which is just an old unused version of the character I made for this game jam entry. I also imported this duck, who will be the subject of our pixelation experiments. The biggest difficulty of getting this effect running in a game is pixelating only a part of the 3D scene, since in 2D we can just turn the resolution of a set texture down. But in 3D, the closest we can do is messing with how the UV of the screen is sampled to pixelate the whole render, like I did in this one game I made for a jam recently. I could have used the mask to only do the pixelation on a set area of the screen, but that would have made the pixel shift around with the camera, which is not what Gimli's effect looks like. What I needed was a way to get only the model rendered at a lower resolution, and then displayed in a way where the pixel's position and size are unaffected by the movement of the object and the camera. That's when it hit me. A few months ago I was messing around with pre-rendering 3D animation into low resolution sprite sheets, and I could probably use a similar method but in real time to render the object onto a quad at a lower resolution. This actually worked really well. The pixels stayed consistent no matter the position of the camera. The only issue left was that our object was basically a single sheet, but that was really easy to solve. I just needed to match the rotation of the render setup to the rotation of our camera, and that got it to work flawlessly. There was one major issue with this approach. Since we're running a full render for each of the objects that we want to pixelate, our frame times are getting worse for each of the extra objects that we want to pixelate. That means it's time for optimization, yay! First off, I did the obvious thing and called the entire rendering setup when the object wasn't visible. Secondly, I made it so its rendering is called by the script instead of happening every frame, and I made its update frame rate decrease based on how far the object is. Lastly, I added a check to see if there is anything between the object and the camera to make sure the rendering isn't running when the object is blocked by a wall. And with these optimizations in place, the effect is running great, even with a lot of pixelated objects on the screen at once. And we're done! You can make any object pixelated while keeping the rest of the scene high resolution. Now, is this useful for anything? No, not really, but it was fun to make. Anyways, thank you so much for watching. If you liked the video, leave a like, or else I'll take another year break from uploading actual content.
マウスに移行するのは確かに難しかったです。私は神経質になります。そして私は全く新しいダイエットをしています。できればチーズ、母、